Welcome to Bandera Plastic Week. Welcome to Bandera Rigid Film Extrusion World. I am Gabriele Murano, Sales and Product Manager of Bandera Flat Extrusion Die Department. Today we want to show you the reasons why Bandera is recognized as a worldwide leading manufacturer of PET and polypropylene sheet extrusion lines, able to achieve incredible results in the last 20 years in terms of number of installation and quality performed by its machineries. The key to our success is the patented co-rotating twin screw technology, which set the pace in the industry and paved the way to processing dryless PET post-consumer flakes and high-quality polypropylene films. Facing the new targets of tray recycling, Bandera is offering to its customers cutting-edge solutions for sustainable PET and polypropylene packaging, featuring barrier properties whenever is required. In the next chapters, we will detail you our latest achievements and our future targets on both the PET and polypropylene horizons. Before doing that, I will introduce you to our fantastic R&D instrument, the Condor line, which supports the Bandera team for the concrete execution of its innovative ideas. The Bandera Condor line is probably the most complete and innovative extrusion equipment ever designed. It is installed in our house of extrusion and available for R&D purposes of Bandera and above all for its customers. To satisfy the upcoming challenges of the market, it is configured with two separate extrusion zones, the substrate section and the coating island. The substrate zone includes three co-rotating twin screw extruders for the production of sheet made of different polymers, such as polystyrene, polypropylene, PET and PLA, including also other biomaterials. When required, the twin screws can process polymers with mineral fillers in pellets or in powder through side feeders, or to provide physical foaming by gas injection on the extruder barrel. One of the major benefits offered by the Bandera twin screw is the degassing efficacy in processing PET, PLA and polystyrene with no pre-drying. Obviously, this will reduce production energy cost. Similarly, such an efficient degassing improves also polypropylene quality. Downstream the substrate zone, the 9-layer coating station is equipped with single screw extruders to customize the final product structure in order to meet customers' needs. The extrusion coating configuration allows the production of very thin and accurate layer thicknesses, up to 1 or 2 microns, delivering amazing quality and flexibility, above all compared to traditional co-extrusion design. The adhesion to the substrate is definitely more performant and steady compared to standard lamination solutions. The aesthetical properties such as transparency and brilliancy are indisputably better compared to other technologies. All these features are highly appreciated, above all when processing functional and barrier raisings. About operations, the Bandera extrusion coating island can be supplied as a retrofit for existing sheet extrusion lines, or just like roll-to-roll configuration, using reels produced by standard extrusion lines. The Bandera Condor line has been our instrument for progressing into the PET sheet tray-to-tray application and polypropylene and biomaterial for coffee capsules.
Over the latest years, plastic single-use cups have become greatly popular in the most different applications, such as coffee and many others. The most common solutions are made of polypropylene and features EVOH barrier layers. Extrusion coating line offer high flexibility in the production of this structure, thus favoring barrier layer asymmetry and optimizing the use of tie resin and EVOH that significantly affect cups' overall cost. By means of extrusion coating, Bandera can use high quantities of recycled material and thermoforming scraps in the substrate without any viscosity fluctuation issue, as opposite to the common co-extrusion in one die only. The production of compostable cups has become a market need. Coating line flexibility and the twin screw dryless technology offer the change to process polypropylene and biopolymers independently. Allowing for thermoforming industrial scrap reuse, they provide for significant cost saving on receipt and a reduction of high biomaterial cost impact, with no degradation and keeping the virgin quality level.
Good morning to everyone. thanks to Bandera for this opportunity. And let me present in this talk the state of the art of recycling and the possible opportunities of RPT in trace market. I am Roberto Tangorra, Quality and R&D Manager of Dentist Group, that today is a consolidated reality in the European panorama in the mechanical sorting and recycling OPT, with 3 different production sites placed in Italy, in the Piedmont region, where it is placed even the headquarters, Spain close to Valencia, and France, with a company specialized in the engineering of recycling machines. Specifically, the group is made up of 120 employees with a total capacity more than 180,000 of bottles recycled last year. Specifically, with used 40,000 in Italian dentist recycling plant, 90,000 tons of bottles recycled in the last site in Spain, Pet Compagnia para su Reciclado, and the last 40,000 in the new revamped plant Nord Palplast in France. Before addressing the main topic of the talk, I think that the first question on which it is necessary to face to is try to answer why PT. Surely, I think everyone knows very well and better than me about the importance and unique thermomechanical properties of PT for packagings. But what we should necessary to be emphasized that today PT is the only one among the other polymers to be considered 100% recyclable, and the only one with a robust industrial and legislative supply chain pipeline to be considered recyclable. And on this topic we can get back later in the next slides. But if this is everything all true, why we are continue to be bombarded with this kind of image? I think that the answer may perhaps be sought in a failure to fully apply the concept of the so-called EPR, the responsibility that the producer holds in managing the end of life of the packaging, directly or by delegating it to a possible consortium for its collection, sorting and handling. And specifically on these themes that the European Commission has started to be focusing for a true implementation of a circular policy for plastic packaging. This strategy, also reported in March 2021 in the Green Deal report, is mainly based on 3 different pillars that consist in expanding and improve the separate collection of plastic waste, in improving eco-friendly packaging design, and creating new viable markets for boosting the recycled plastic demand. For this purpose, the European legislator has identified in the so famous single-use plastic and packaging waste directives different targets that I think that everyone already knows very well. So, where we can find the targets of 77% of PET bottles that needs to be collected within 2025, that get rising up to 19 in 2029. The goal to maintain a content of 25% of RPT in PT bottles, which will become 30 in 2030, and above all, the target of at least 50% of plastic packaging that must be recyclable in 2025, that getting up at a minimum of 55 in 2030. So, focusing on on these goals so far, which is the state of art of PT market? Based on the last Eunomia report in 2018, on the total of 4.8 million tons of PT placed on the market, 3.4 million are were used for bottles and 900,000 for PET trays. Of this quantity, just 22 millions were collected, and 1.9 actually sent for recycling, obtaining a final recycling of just only 52% of PET bottles, of the 50 bottles placed on the market, and only 120 million tons of trays collected and really recycled. So up to now is still evident that the real bottleneck for true recycling remains a real good collection systems. In fact, if in this chart, as we can observe in this chart where it is reported the collection yield of the European, we can focus, for example, on for Italy, where only the 52 were collected in 2018, and according to the last report of Correpla, the yield rose up to 58, but quite far from the 77% imposed by the European Commission. Moreover, of the quantity that it is then recycling, today mainly the 30% it is used of sheet, that it remains the main application for LPT market, and 28% for food for injection and blow molding. But what is interesting to know that if we compare the quantities of RPT with respect to the ones placed on the market, we can observe that the trays have been produced by averaging 45% of recycled PET, while for bottles production just the 11% is used, compared to the target of 25 that imposed by the European Commission. However, if we projecting towards in the pledge era in 2025, we can safely estimate that to meet the minimum target of 25% in PET bottles, just focusing for example in Italy, we need to allocate at least 45 all recycled RPT production just for PET bottles. So it is clear that some questions spontaneously can arise for the world of the market of trays. The post-consumer PET bottles collection will be enough for all recycling PET, or the new PET bottles goals and markets will eat all the requests of recycled PET. So where we can find a new source of recycling PET for trays. So I think that this first important take-home message of this talk, that a new paradigm is urgent. Try to shift from bottle to trays way up to a new paradigm where we can find trace-to-trace recyclability. To make really trace recyclable, but different challenges are to be faced. First of all, we need to improve the amount of PT viable for PT mechanical recycling. So we need to develop a new industrial model for PT collection and sorting. Moreover, we need to improve the quality of our PT streams, increasing, for example, dedicated streams for PT bottles and dedicated streams just for PT trays. Then, following the mission delivered to us by the Commission as a fil rouge, it's clear that a close collaboration is needed to catch up a real design of trays that can make them truly recyclable in order to reach the so ambitious target of 55% of plastic packaging to be recyclable within 2030. But what does really means this phantom word recyclable? Numerous efforts are underway to reach a definition of recyclability standards, but today make our own the definition shared by PETCOR and American and European Association. We can consider it a recyclable packaging, a recyclable product, not only the product that has been already designed for to be recyclable, but above all the packaging that need to have a consolidated supply chain in the collection system, in the recycling phase, and needs to present a secondary market in which it can be valorized as a secondary raw material. So it is clear that a really close collaboration among all the players, not only producers but also collectors and recyclers, is urgent to promote and boost the trace recyclability. In fact, today, as we report in this slide, we can consider the trace recyclability quite low. In fact, only the monomaterial is technically recyclable, but they present to date a totally undeveloped market, which leads to not fully exploiting this kind of product. In fact, there are different technologies that can allow the selection and sorting of monomaterial trays, even all the colored ones, but the trays nowadays are just sent for recycling in a very small quantity, often diluted in the bottle streams. Recycling is shown in low yields due to the different properties of the polymers used for PT bottles and PT trays. Oppositely, multi-material trays find a very difficult application in mechanical recycling due to the impossibility to find a way to sort and separate in a efficient and economical sustainable way PT from the other polymers. On the other hand, new application for chemical recycling can be envisioned for in this case, for example, highlighting another times the fully complementarity of mechanical and chemical recycling. For this purpose, I recommend to follow and support the Recyclas platform that is presenting and providing very useful indication and evaluation for the definition of a recyclable packaging. For example, according to the last guidelines, a PT trays can be considered mechanically recyclable if, for example, it needs to be, if it contains monomaterial polymers or delaminable ones, if we use colors that can be detected by IR, new pigments, for example, are coming on the market for black. Avoid the presence of UV oxygen scavengers that can lead to the yellowing of the material, making tops without labels and with the opening method that can reduce the presence of glue dots. Use PT, PE or labels that can be easily separated in the flotation sink. And finally, prefer adhesive water or at least alkali soluble wool to be separated in the recycling plant. So, moving towards the conclusion, it is clear, I hope, that in order to achieve the target of these ambitious goals imposed by the European Commission, it's urgent and necessary a really development of a close collaboration of all the players in the supply chain, starting from the packaging producer, collection consortium, and recyclers, in order to work together to improve the quantity and above all the quality of the selected packaging flow collected, such as with homogeneous streams for trays, optimizing PT sorting capacity, supporting a new design for a true recyclability of the packaging, as we already described, in order to finally achieve the development of a new consolidated market for application of recycled PT from PT trays, in which, as dentists, we fully believe, and for that reason we are really proud to be a very close partner with a standing collaboration with Bandera family. So thanks a lot for your time. I hope you enjoyed and find interesting this talk, and for any kind possible question, please address me by mail. Thanks.
Parallel to PET, the polypropylene packaging market is having a very interesting development with the aim of optimizing the standard generally attributed to polypropylene film. The rigid packaging and the for-fill and seal market are requesting a certain combination of characteristics for the satisfaction of the various final applications, down gauging up to 180 micron, high transparency comparable with PET, ensured barrier performance, confirmed thermic resistance for pasteurization and other high temperature applications, better control of the layer thickness, above all the adhesive and the barrier resin, customized glossy surface, appropriate shrink level. Bandera developed two dedicated technologies to meet these needs. The first one is a dedicated extrusion line with reinforced calendering to obtain transparent foil, glossy on both sides, and with thickness values ranging from 240 micron to 1.8 millimeter. The second technology, which is a more flexible and offers a wider application range, features a cast film line powered by a customized solution coating station to reach wider thickness range and higher transparency. The mono or multi-layer cast film equipment produces the substrate afterwards coated with a specific layer structures, ensuring barrier resin application and astonishing transparency level. This solution offers the widest production ability available in the market, from 180 micron to 2 millimeter, combining the most appreciable benefit in terms of quality, accuracy, and control.
The for-fill seal market is more and more in search of sustainable solutions for oxygen barrier food packaging to reach the goal of tray-to-tray recycling. Relying on coating technology, Bandera is exploring new frontiers to obtain PET-based monomaterial structures with barrier additives in cutting-edge configurations. The results experimentally achieved are far better compared to the other available solutions in terms of optical and barrier performance, mechanical properties, and reduced overall thickness. Thanks to the accurate thickness control by its coating station, Bandera technology offered the chance to produce barrier structures with materials such EVOH, minimizing the overall quantity of polymer other than PET under 5%. In this way, the end product could be identified as monomaterial for many worldwide countries, and its industrial and post-consumer recyclability is drastically increased.
Thank you very much to our friends in Bandera. Thank you very much to have this time to explain you the WM thermoforming philosophy. Today I prepare a presentation that is showing how is living in thermoforming. So principle, data and value that are driving our market today. Plastic is very important material and we have to take care about it. This one can be done thinking about the 3R, so reduce, reuse and recycle. Very important to have this material in the future. We are part of the life cycle assessments. Very important to understand if a process, a material, a product is sustainable or not. We are taking part about this process as WM and as private persons, and this one is very important to understand. In WM, we are, as a machine manufacturer, we are more involved on stage 1. That is considering the developing of our technology in order to rationalize the process. So we have to innovate our process, and this one is possible looking inside our process, but looking also to the market and to the feedback we are receiving from our clients. This one has been done since we are producing thermoforming machine, and so we had the possibility to reduce the energy consumption with the new bank heater, insulating system, new ceramic elements. We are using on all our machine a multi-axis synchronization, so we are rationalizing the acceleration and deceleration of our motor in order to reduce the consumption, having in any case high speed. We introduced, for example, the Venturi system instead of the vacuum pump that is reducing the energy consumption, and we have drives energy recovering standard in our machine. When we are speaking about the material, we introduce a new stacking system where we can have less material between the cavities, so we have the same productivity with less material. If you want to use less material, you have to take care about the stretching, so the forming, and this one can be done through a precise plug assist, and this one was developed in WM also for deep draw. Higher efficiency, less downtime. This one is related most of the time with the cutting station, so because of that we have a very robust cutting station, and this one means that you can wearing less the knife, having better stability of the process. It's very important because this one is really what is giving to you the stability of the process. When we are speaking about all the other data that are moving the process and the quality, we have a drift process monitoring, so we have sensor, we control the maximum and minimum data possible in order to maintain the quality. When we go outside this range, we can retrofit the machine, changing the parameter, maintaining the process stable. This one, for example, is done also on the cooling device, so we are controlling the cooling of the mold, that is very important in order to have a better process. We've done much more, and for sure, if you are interested, we can discuss after this meeting. Now we are all focused to find a sustainable material for the future. Sustainable material means that we can recycle, and obviously we have to recycle. In order to do that, is better for all the process of recycling to have easy material, so less material possible and not multi-layer. So monolayer, easy to recycle, possible to separate and sorting in the recycle plants. Maybe a material that after recycling we can increase a little bit the characteristic, for example for PET, the IV. Material with a wide range of mechanical and physical characteristics, and at the end, when we got all these data from our material, we have to have the possibility to have reliable costs that are bringing this application, this material into the market, as well as the availability. When we are looking on thermoforming, most of the time we are producing PET and polypropylene, and how we can decide which is the material better for this application. We have to study the behavior of the material. This one is an example, a case study. In this case, we can see how the density is completely different from PET and polypropylene. The relation between the thickness and the stiffness is completely different, and all the other characteristics. We worked it out, and we found out that for the same product we need 22% more weight on the PET in order to have the same stiffness. And so we can say, no, PET is not okay for this application. No, obviously we have other data. If you are looking, for example, on the power consumption, we are using 22% more material, but the energy consumption used to process this PET is less than polypropylene, because polypropylene has a higher specific heat ratio, so means that it's taking more time to heat it up and more time to cooling down, more energy. And this one is giving to you also the possibility to run with PET at 32 cycles instead of 27. So all these data are bringing the real cost of the product, but at the end, more or less for this product, we find out that the price can be very similar. Obviously, is driven from the cost of the roll, but time by time you can go up and down depending from the market. Why PET took a strong position in the market? Because we have the bottle flakes, so the recycle of the bottle, that are bringing into the thermoforming market, and we have a lot of recycled material in our final trays. This one is possible because the bottle is recognized from the end user, is easy to sort in the recycle plant, is monolayer, high quality of the material, and so we are bringing the closed loop. So we are producing the trays, we have material coming from other application, we can regrind and use on the trays. During this year, technology is improving, not only in thermoforming, obviously in extrusion and recycling, and bottle-to-bottle comes, and bottle-to-bottle is decreasing the possibility to have the regrind use on the thermoforming. So the next generation, the next technology that will help the thermoforming to be sustainable, to have is closed loop, is the tray-to-tray recycle plant. So why WM thermoforming machine? Why somebody has to choose our technology? We explained before our philosophy on improving and developing. We know all the details that are bringing this market to be sustainable, and also inside our company we have some specific focus when we are building up our machine. For us, is very important to ensure that our machines are easy to use. We can increase the technology inside our machine with the sensor drift process management, but the machine on the base concept has to be very easy to use. This one because we have to shorten the learning curve. So when we know how to use something, after that we can increase the technology for the skilled operator. As explained before, for us is very important the cutting operation. For sure is the part of the machine where we have something that is wearing, that is the cutting knife. If you have a very stable process in this area, you can have the stable process in general. So you are forming in the right way, you are cutting, you are stacking. Without the cutting, you can be as fast as you want, but you will not able to stack properly. And for us, the perfect cut is what is driving our developing our technology. In order to do that, we increase on PET the clamping force. We saw before that we need more power to cut the PET. More cut means that the machine has to improve the rigidity, because otherwise I have more elongation of our column, and the elasticity is wearing a lot of our knife. So less column elongation, a perfect parallelism, otherwise I'm doing a wrong job on when I'm cutting. Symmetric double toggle system to distribute the force in the right way and to reduce the vibration, and all the yoke that I have inside our station, we introduce the stacking dynamic yoke reset. So having this station stable will ensure the stability of the process, and so energy consumption, less material use, and sustainable process. Here we can see how we improved during the year the clamping force of our machine, having the more PET in use from our clients. This one is our station, double toggle system, symmetric, no vibration, 4 column, zero deflection of the plate, and this one is what is giving to you the stability of the process. As we told before, life cycle assessment, we have to always think that we are all part of this process in order to have a plastic sustainable future, and in our daily life reduce and reuse and recycle. We have to take care about the material, because it is not something that is unlimited, and the process of developing is driven by having some goal. For sure you have to solve some problem, you have to think about this problem, you have to design a new way of doing, and you have to do this one as fast as possible in order to maintain the company in the market with the right technology. Thank you very much for your attention. I appreciate the invitation from Bandera. We are also preparing our remote open house the 1st of July. We will invite Bandera to take part of our event, and we will see online.
Hello everyone, and welcome again to the Bandera Plastic Week dedicated to the foil and sheet technology. I am Gabriele Murano, a Sales and Product Manager of the Foil and Sheet division here in Bandera. And here we are with the question and answer time. Before doing that, I would like to say thanks a lot to our partners, WM Machinery and Dentis, and obviously to all the people that contributed to this nice event. It's been excellent up to present, and hopefully also for the next session. Moving back to the Q&A, we have got some interesting questions. The first one is from the UK, Robert K, for WM, for Andrea. Machine clamping force monitoring. PT, can you hear us, Andrea?
Yes, I'm with you, Gabriele. Good. Thank you.
Good. Machine clamping force monitoring. PT requires higher clamping force compared to PS and polyprop. How WM Machinery control it?
Okay. Question. Hello to everyone. Clamping force is a key point for us, for WM Machine, is one of our key advantages, having most likely the highest clamping force available in the range of thermoforming machines. Specifically on tilting, so cap machine, on tilting thermoforming machine, on single station, punch and die, we do control clamping force by having load cells on each right and left arm on the forming station. So it's possible to control the clamping force by monitoring how much clamping the machine is taking at any given cycle time. So it means that for every cycle time during operation, machine is the system show operator how much clamping the machine is taking. It's possible to set 2 levels of alarm. The first level is just an alarm, so the machine is telling you that it's getting close for some reason, is getting close to the maximum clamping force available, but it doesn't stop the machine running. At the second level, once the machine really reach the maximum clamping force available, automatically stop to prevent any further or any mechanical damage. So obviously the 2 levels, alarm and stop, are set by the operator based on his own experience, knowledge, product to run, material. We know that, as you said rightly, PET requires higher clamping than polypropylene. Nowadays, with the new materials coming up, specifically PLA, just thinking about caps again, PLA requires even higher clamping force than PET, in a range between 5 to 10% higher than PET. So it's a key point to have a machine equipped with a system to keep under control all the way the clamping force, and the machine have been built structure strong enough to develop such a high clamping level.
Good. Thanks, Andrea, for the explanation.
Thanks.
Then we have 2 questions for Bandera coming from Spain, Mr. Jordi. It's what is the minimum thickness achievable for polypropylene production, and why polypropylene is processed with the twin screw degassed? So about the thickness achievable, we can run starting from 150 micron for the non-barriered film and 180 micron with the barrier resin included. Regarding the polypropylene processed with twin screw degassed, polypropylene is not an hygroscopic material, so it does not absorb moisture, but in any case, for quality reasons, we recommend the use of twin screw degassed because of the rheological characteristics, so low shear stress applied to the polymer and the degassing efficiency in order to let's say, decontaminate the polymer in molten stage by the residues coming from the polymerization. Then we have got a question for Roberto and Dentis, a question coming from Roberto from Naples. Have you ever experimentally tested the trays grinding and washing operation? And if yes, which are the most critical issues compared to the bottle flakes production? The microphone is not working, Roberto.
Okay, sorry. Can you hear me now?
Yeah. Would you like me to repeat the question, or is it okay?
No, it's okay. So thanks, Gabriele. Basically, nowadays, trace to trace are still an experimental way, since we don't have any specific stream already dedicated. So as a recycler, we are totally involved to create a solid and robust volume fully dedicated for trace. Going to answers, it is important to have 100% trace streams, since the use of trace in dilution can create some issues that you can also manage it when you use trace, that flakes can make brittle, and can you have a drop off on IV. But all the existing washing lines are already ready to manage it, and so we're not envisage any problem to will be ready for recycle directly trace to trace.
Good, thanks a lot for the explanation. Another question for WM coming from Germany, Mr. Thorsten, and it is about the operativeness. He said, COVID-19 situation deeply affected the commissioning phase at the customer site. How WM reacted in the past and will react for the future machine installation and startup at the customer site?
Okay, yes, this is correct. But let's say that since the beginning of COVID, so back to February last year, we have developed a certain procedures, which in short means what we call tutorial videos, enabling customer in step-by-step machine installation, connection, and startup. So by doing this, we were able to start up successfully machines in USA down to Australia, or from Korea to South America, passing by Middle East, Dubai, Saudi Arabia, Russia. I'm talking about machines, cap, tilting machine, as well as 3-4 station machine, small size, medium size, large size. In one case, we were also able to start up a complete inline system, means extruder feeding directly the thermoforming, by those tutorial videos. It's clear that according to customer experience knowledge, this procedure might be very, very smooth and fast, or it might take a little bit longer. But specifically nowadays, in some areas, in some country, this is the only option. Keep in mind that our machines' big advantage is that they come on a single frame. So it means that I'm thinking about a 3 or 4 station machine. They can forming, cutting, punching, stacking station in a single frame. So it's quite easy to connect and start up the machine. Different than competitors when we deliver machine in blocks, station by station, which requires a longer assembly time, and for sure longer time and more experienced people to do this job. So basically for us, we have seen in the last couple of months, in 3-4 working days, by helping customers from a remote service in WM, we were able to start up all machines successfully. As of now, I don't have any clue or any information of a machine not being installed or not being running because of COVID. We were not able to send our engineer abroad.
Good. Thanks a lot, Andrea. Always ready for the challenge, also the future ones. Then we have the last one for Bandera that is coming from Austria, Mr. Gerhard. PT sheet for food contact made with monolayer or multi-layer structure, which is the correct formula for the EFSA compliance. Obviously here we are speaking about European criteria. There is not a correct formula, both can be used. The monolayer is referred to a certain regulation, the CE regulation 282 dated 2008, where there is a certain strategy and a certain challenge test to be performed in order to be compliant with this monolayer regulation for food contact. Vice versa, the multi-layer is following another path, another route, which is the CE regulation 10 dated 2011, where the ABA, the multi-layer structure, is foreseen, and each provider of packaging material to the market is to make a kind of self-certification with migration test to be performed with a certain frequency. So nothing else at the moment coming from all the participants. So I would like to thanks a lot WM and Dentis for the availability, and see you for the next session. Goodbye, arrivederci. Thank you.